And we're live. Once again, welcome to the show. My name is Michael Lynn, and this is the MongoDB Podcast Live with another amazing stream for you today. Make sure my camera's set. I'm so excited to talk to our guest today. His name is Ben Perlmutter. He's a senior education engineer, and he's built something pretty cool along with the team in the engineering team here at MongoDB. It's a framework that allows you to build an AI assistant, very much like Chat GPT. And we're going to dive deep into how that was built and look at the foundational elements, the components required. We're going to show you the code. We're going to show you what it's like to extend it. If you're joining us today, I'd love to hear why you're here. What are you interested in? Do you have specific questions around building an AI chatbot? And I'd love to learn what you're building. If you're building something cool, I want to know about it. I'm also curious about where you're from. Hey, Luce Carter is moderating for us once again. Thanks so much for all your help with all these streams. She's in sunny UK. Where in the world are you joining us from? If you're hitting the stream, you're interested in building an AI chatbot, you're interested in the framework, let me know where you're coming from and get your questions ready. Okay, enough jabbering from me. Without further ado, let's bring Ben on. Before I do, I just want to remind you, this guy's been on the show before. He was our guest on episode 190 of the MongoDB podcast. That's an audio format available on Spotify, Google Podcasts, YouTube, Apple Podcasts, all over the place. Let's bring Ben on stage. Welcome, Ben. It's great to have you back on the show. How are you?
Thanks, Mike. I'm good. It's good to be here.
Yeah, it's good to have you back. So what's going on? Some great stuff happening with the ML chatbot framework.
Yeah, so we've been working on the MongoDB Chatbot framework since we first started on the kind of prototype of this project. That was actually a bit over a year ago. And now we have our instance in production, and we have this framework, which we released a couple months ago to share with y'all.
Fantastic. Before we dive into the framework, maybe let folks know a little bit about yourself. If they haven't heard episode 190 of the podcast, maybe they don't know a little bit about your background before we dive into the topic at hand.
Sure. So I've been at MongoDB for, I think, 2.5 years now. I started out here as, my job title was education engineer, but it was, I would characterize it as very technical writing. So writing some of the documentation for our developer SDKs and drivers, including like Realm, Flutter, and the Kotlin driver. And while I was working on that, I basically, from the moment Chat GPT came out, I got pretty hooked on this whole generative AI thing. I think that came out late November of I'm losing track of the years now, 2022.
Do the same thing.
And I think it was like the first week of December of that year that I started building my first app with it. Fast forward a little bit, during this internal hackathon that we have here called Skunkworks in March of that year, or 2023 now, I suppose. We are in the timeline. So just about a year ago, we built our first prototype of the Docs chatbot, which you can find on every page of our documentation website, using this paradigm called retrieval augmented generation. Although honestly, at the time, I don't think I even knew that it was called that. We just knew that we could use Atlas Vector Search and our documentation as source data to create this interactive chatbot, and it worked pretty well. A little bit later, some folks tapped us and were like, hey, could you put this on our Docs website? And then we did.
And the rest is history. Well, if you want to check it out in production, you can visit mongodb.com/docs and ask some questions about MongoDB. I love the way it works. And I'm really interested to dive into the details of how it was put together. I know it started as a Skunkworks project, but how did you do? Did you win?
Not only did we not win, we did not even make the finals.
That's pretty crazy. There were some pretty amazing projects. right alongside.
And there's a lot of AI stuff that time around. So I imagine they only wanted to put like 2 or 3 AI things in there.
Yeah.
And we didn't quite make the cut. We'd actually won the previous Skunkworks.
Oh,
So
it
maybe
did?
that was a factor as well. Yeah.
Okay. So no retreads. Yeah, we had we had Jesse and I worked on, and a couple other people on the team worked on a project for that Skunkworks around MongoDB TV and the back end and administrative interface, and it didn't do well. But it's an amazing system that's in production today. So
that's what counts. That's the real win.
Yeah, exactly. Yeah. So speaking of production, I want to I want to talk a little bit about lessons learned. There are not many really large scale AI projects in production today. What lessons did you learn when you rolled it into production?
So we learned, I'd say, a lot of lessons pre-production through the red teaming process.
Mm-hmm.
Basically, that's when you have users come and test your system out systematically and document their findings.
Yeah.
And through that, we were able to catch a lot of like kind of the corner cases where things weren't working quite as well as we'd hoped. And then we're able to fix those before the app got into production. And when that happened, we actually felt it was working pretty good, but we of course still wanted to make it better. But we found that making it better when it's already working pretty good is pretty hard with these generative AI systems, because you don't want to like tweak some knob, and maybe in your individual testing or the red teaming, it still works well, but it exposes some new whole category of issues. And that has led us to create an evaluation framework, which we're going to touch upon today as well.
Okay, great.
And
Well,
that can help kind of systematically address these issues and hopefully at least catch them before they hit production.
Yeah. Well, I want to dive right in. And I know you have a little bit of a deck, not to fear people. We're only going to spend a few minutes covering the architecture, some of the components. And I think it's really important for us to kind of set the stage for how this was put together. So what do you say, Ben? You want to jump right into it?
For sure. So let me figure out how to screen share.
While you're doing that, I want folks to know we're actually going to take a look at the code, and I'm going to share a GitHub repository where you can find examples of this code. And I would love to ask folks, if you go through the trouble of typing that URL in, oh, that's the exam. Is that the right URL, Ben?
Oh, that's
GitHub
the doc site.
That's the doc site. Darn.
You can check that out too.
I blew it. Yeah. So what I'll do is while you're getting the slide deck up and ready, which I see, I'll fetch the GitHub repository, and I want folks to know that we're going to post a link to the GitHub repository. I want you to star it. So let's get into it.
Sure. So we're going to take a quick look at what the MongoDB Chatbot framework is before we look at some of the code and working site using it. We're also going to talk about the various components that constitute the framework, how it uses MongoDB Atlas and Atlas Vector Search, and give a quick overview of the demo that we're going to build together. So the Chatbot framework is full stack, meaning it's client, in this case, a web UI, server, and database, MongoDB, of course. And you can use this to build AI chatbots, think like Chat GPT, but on your own website. And we provided first-class support for this popular generative AI application building paradigm called retrieval augmented generation. And this is basically the idea that before a AI model, usually a large language model, responds to the user, it pulls in some data from somewhere else to augment the generation. And this makes the answer better, typically, less likely to hallucinate, and you can just have data that isn't inside of the AI model already. We've built this framework using TypeScript, which is something of a differentiator as compared to a lot of other AI chatbot frameworks out there. There are a few, but those tend to be in Python. So we wanted to give a full stack TypeScript experience. And we've built this upon the MERN stack, the popular web application development stack with MongoDB, Express for our server, React for the UI. And we also include a couple of AI-specific CLI applications, which we'll talk about in just a moment. We've built the framework to be incredibly pluggable. Basically, it's some TypeScript interfaces that you can plug into with glue code between them to handle things like routing of chat requests, streaming back to the client, data ingestion. And this allows us to support a very diverse array of AI models with not too much friction. We've tested it out using Azure OpenAI, just OpenAI from OpenAI, Google's Vertex AI, Cloud, and it can work with some more. And you can use LangChain and LlamaIndex, these popular AI application building libraries to help you do that, so you don't need to start from scratch either. We also have made it easy to optimize the framework to your use case, so you can bring your own prompting techniques. We're actually going to look at bringing in a prompting technique called step-back prompting in our demo, and different ingest strategies, chunking strategies, things like that. And as we discussed before, we have built this framework informed by our experience building the MongoDB AI chatbot, which you can check out on mongodb.com/docs. So our experience building the chatbot informs what we put into the framework, and our thinking about the framework informs what we put in the chatbot. So it's something of a virtuous cycle for us.
Mm-hmm. I think they call that dog fooding.
You could also call it that. I prefer virtuous cycle.
Right.
Anyways, the framework has 4 core components, each of which corresponds to an NPM library, which you can download from NPM today. We have our server, which is the Express.js server that manages conversations and persists the data to the database. We have our React UI library that has a chatbot UI. You can talk to the server. Our data ingestion CLI that can pull data from a wide variety of data sources into a database indexed with Atlas vector search that you can then query in your chatbot application. And most recently, the evaluation CLI, which you can use to evaluate how your chatbot is performing, so you can build and test with some more confidence before putting things into production or having to do like a very labor-intensive red teaming exercise.
Mm-hmm.
And all of this, of course, has been built upon MongoDB Atlas, using MongoDB as our operational data store. We also use Atlas vector search to index our embeddings and its associated content for use with retrieval augmented generation. And you can use the rest of the MongoDB Atlas as well to augment your application. For example, you might want to add some Atlas charts to visualize what's going on with your likes and dislikes. You're getting more likes than dislikes, how ingestion is working. If your app blows up, you can use auto scaling to take your cluster from a M10 to M2000. I don't know if that's a real one, but you can go big and it will work seamlessly, plus the rest of the features in the Atlas developer data platform.
Fantastic. I love the clean design and how you've broken it down into components. And if you check out that GitHub repository, you'll see that there's a nice architecture, a nice breakdown. The separate components are available for review as code, but they're in the packages directory. So if you want to check that out, make sure you give us a star. We're going to see if we can't get some attention on the repository as a result of today's show. Okay, so what's next?
Yeah, now it's demo time.
Mm-hmm.
So we're going to look at a app that I made for this demo called the Gilded Age Gourmet. This is a retrieval augmented generation application made with the chatbot framework that lets you talk to the Fanny Farmer cookbook. This is a classic cookbook in the American tradition. Has some turn of the 20th century, like very classic American recipes. And importantly for our use case is also in the public domain. So we can use it without having to worry about lawyers or such things.
Yeah. Okay. So it's a perfect example because like, what I said in my post prior to the stream was like, if you want to build a custom AI assistant, the key thing is training it with data. And what you've done here is you've leveraged the framework and you've built on top of that via RAG, retrieval augmented generation. You've provided it with information about something pretty specific, very simple, but pretty specific. Recipes from 1896. So I'm interested to see how this comes out.
Sure. So let's take a look at the code now. So we're going to start by just taking a very brief look at what the data is that we're going to be talking to. So I found this cookbook online and then I converted it to Markdown and saved it here. You can see that just plain Markdown text.
Mm-hmm.
This cookbook is interesting in that it has like almost a philosophy of food as well in it,
Mm-hmm.
talking about air and moisture and what these are, how they pertain to food, in addition to just some recipes as well.
Yep.
Like cream scones, for example.
Hmm.
Yum.
Yeah.
Anyways, now that we've taken a look at the data, we can see how we would ingest it to use with our chatbot.
Mm-hmm.
We do that using the ingest CLI package, which is defined in a configuration file, which you can see here. And in this configuration file, you can define a variety of things, such as what is the vector embedding model which you're using that will work with Atlas Vector Search. Here we're using the OpenAI Ada 2 model. Then where you store your data, you can also define, and how you chunk your data, because usually with retrieval augmented generation, you're not just going to take full pages because they can be quite long, especially when you're dealing with web content. You want to chunk it up into smaller pieces. So you can define your chunking strategy here, and also your data source, which is how you pull your data from wherever it's living, in this case, Markdown files. Although you could also do HTML, PDFs, what have you, into the chatbot.
I don't want to slow you down, but I want to ask about the location that you're storing and then the chunking strategy. So first of all, can folks pretty much leave the defaults that are in the GitHub repository if they fork this? Or do they need to know, like, what do they need to know in order to make this work for themselves?
Great question. So if you were to use this yourself, the main thing that you'd want to change is the data sources. You want to add your own data, unless you just want to make a cookbook chat, of course.
Right.
And
Okay.
we give you a lot of flexibility there in defining your own data sources.
Yep.
But then the rest of it could probably stay the same. Maybe you want to do a different embedding model, but that's easy to add as well.
So go back to the source, and is that pointing to a GitHub repo?
So
Cookbook
this one
source.
is pointing to this GitHub repo.
Okay. Yep.
But you could also just have it point to the file system. So it's reading from this directory.
Yep. Great.
Basically, it's just an async function. So if you can get the data asynchronously into JavaScript, you can use it in your chatbot.
Okay. And this is the RAG component, right? It's ingesting these files and it's going to essentially train, right?
Yep. So this is the RAG ingest part, and then the RAG
Yeah.
query part we'll look at in a moment.
Okay, perfect.
So without further ado, we can actually run the data ingestion.
Okay, that's really tiny. Can you make that a little bigger so we can see that?
Yeah, and let me clear this as well.
Yeah.
Oh, too small.
Okay. Hope that's maybe one more. There
Two
you
more
go.
for good measure.
Two more for good measure. Yeah.
All right. Now this is my terminal being funny. Okay, here we are at the bottom.
Okay.
So we're just going to run the ingest command, which is just a command from the package JSON that calls the ingest CLI.
Okay.
Wrong package JSON. This one, yes. So we're going to run this command.
Gotcha. Ingest all.
All right, so now the data is ingesting. This will probably take about a minute because we need to create all of those embeddings. But while this is building, and you can see the embeddings being created now, while that's building, we can create our Atlas vector search index, which really just takes a minute.
Once again, can I ask you to pop the size of that?
Yep.
Yeah, there we go. Good.
So we're right now in the Atlas UI, creating the vector search index.
Okay.
We are working on the dev version. So we will just fill this in using actually the defaults from the quick start. This will work for most
so this is the index definition. Okay.
Yeah, so this takes the MongoDB collection and turns it into a vector database, basically.
Where can folks get that data? Get the data for the cookbook?
Like in MongoDB.
Oh, I see. I see what's happening. So you've, in running the ingest, you've specified the location of your Atlas database, and that's ingesting into your Atlas database, into the cookbook database and the cookbook collection. Okay, I got it. I'm slow today.
Oh, good. So we pull the data from those markdown files into MongoDB, into this collection. But right now, it's just a plain old MongoDB collection. We can't do vector search with it yet, but when I press this button, we can. It's pretty easy to make a collection indexed by vector search. I think this will take about a minute or so to set up. So while that's being created, we can take a quick look at the data. So you can notice that there's two collections that we ingested here.
Yeah, need a little bit of size. Turn that up a little bit. Yeah,
there we go. So the first one is pages, which basically copies the data from the original data source in the format that it was, without chunking or anything. Maybe if it's HTML, you want to convert it to Markdown, but it can theoretically be in any format. And it takes the full page, and then we chunk it up into this embedded content, where one page can have one or many chunks depending on the page length and your chunking strategy.
Okay.
And also in here is this embedding field that contains that vector embedding array, which we just indexed using Atlas vector search.
Yeah.
And now that index is active.
All right.
Or is it? Interesting. It looks like the index was not created.
Okay.
Not sure why, but we can try again. Because as we just looked at, it's pretty easy.
Okay.
There we go. So it's creating, not sure what just happened there.
Wouldn't be a demo if something didn't go slightly awry. Yeah.
Yes, the joys of live coding.
Yeah.
Alrighty. Well, that will take a minute to build, and we can't proceed to the next step, unfortunately, unless this is working. But this could be a good place to ask a question. Do you have any?
Yeah. If you've got questions, let them rip in the comments. And in the meantime, you can also jump on over to the GitHub repository. You could fork that. Do you take PRs?
Yeah, we do. And we're very responsive to issues as well.
Great.
So if you see something,
are there any good first issues?
Not that I can think of right now, but I'm sure it exists. And if you poke around the code base, you can find something.
Yeah.
And with that, actually, our index is built.
Great.
So we can go ahead and run the app. So to do this, we're going to run the server.
All right. And it is
So now
TypeScript.
we have,
Yeah.
it is TypeScript.
Yeah.
So we have our server and our UI running.
Okay.
You can see the server here. Let's just make
Little
sure
bit of
everything's
size.
working.
Yeah. Pop that up a little bit.
Size, always the
Yes.
size.
Always. There we go.
Do you have any questions that you'd like to ask it, Mike?
Yes, I am really trying to make use of this relish that I have in my fridge and hot sauce. I don't know if hot sauce existed in 1896, but let's see what
Yeah, I certainly haven't tried those ones out yet. So
I have: bologna, hot sauce, and relish.
Yum.
John Willis is asking where the repo is. I'm going to pop it up on the screen once again. That's for you, John. github.com/mongodb/chatbot.
All right, a bologna salad sandwich.
Well,
Oh,
that sounds delicious. Now, did it
I'm glad
incorporate
that
the
you
hot
think
sauce?
so. Yeah, mix it with the bologna and the relish. Oh my.
Okay, no hot sauce though.
No, it's in there. It's in there. Bologna, relish, and hot sauce.
Oh yeah, there
I'm
you
going
go.
to let you try that out, Mike, and report back.
All right. Fantastic. Now, what about that step back? That's an important component of a like a modern chatbot. And step back, for those folks listening that may not know what that is, but there needs to be an understanding by the chatbot of context when you ask a question and then modify the question after you've gotten a response. Is that something that has been implemented in this chatbot?
So we haven't implemented it yet, but we can now.
Oh, did I put the wrong repo up, John?
So that is our frameworks repo. The actual chatbot that we're looking at now, the cookbook, is in a different repo, which
Oh, cheapers. Man, I'm sorry. I'm blowing it today.
it's over here.
Okay. Yeah. If you could drop that in the private chat, I'll get it into a banner for folks. And it's linked in the blog, right?
No, there's no cookbook linked anywhere before today. This is the grand debut of the cookbook chat.
Okay, great. I'm getting it into a banner. Thanks for your patience, folks. There you go. This is the cookbook chat. Yeah. Thanks for those comments and questions. All right. So I was asking about step back and how we might begin to modify the functionality of the chatbot. Let's say that folks they've found their document source. They want to create their own chatbot with their own data and documents. Now they want to go ahead and modify it and improve the functionality.
Sure. So I think before we add step back, it makes sense to just take a quick look at what is going on there now.
Mm-hmm.
So right now we are doing what sometimes called naive retrieval augmented generation, which is basically where you take whatever it is that the user put into the chatbot. In this case, what can I make with bologna, hot sauce, and relish? Yum. And then that is turned into a vector embedding. We do vector search with that. That returns results, and the system generates off it. But to make a more robust chatbot, you can do something called step back prompting, where it takes the context of the conversation and uses a large language model to make a search query for it. So in this case, let's say, what can I make with bologna, hot sauce, and relish? Then maybe you're like, actually, I want to add pickles too. Who knows what will come up now? Fellow aficionado of the art of pickling. I love this.
Do we have a hallucination?
Spanish pickles.
Hmm.
Sweet pickled peaches. I think they liked pickling a lot at the turn of the 20th century because they didn't have like refrigerators. There's probably a lot of pickle content in here. But as you can see here, like we're not talking about adding pickles to the sandwich.
Yeah.
And that is because this is what the vector search query is. We're not saying do a search for adding pickles to the bologna relish hot sauce sandwich.
Mm-hmm.
But that's really what we wanted.
Yeah.
So we can do step back prompting to achieve just that. And I've implemented already the step back prompting preprocessor, we call it, which has some general direction for taking the conversational context and creating this better search query to do retrieval with. And we've actually implemented this using LangChain.
Mm-hmm.
And this step back prompting prompt was taken from the LangChain documentation, then like modified slightly to be about cooking. But this took me about like 5 minutes to make, copying from the LangChain docs.
So that prompt is set in addition to the user question, right?
Yeah. So the user asks a question, then an LLM takes it, makes a new search query, does vector search with it, returns the results, and then the chatbot will answer the original user query with this vector search information.
Gotcha.
So now we can add it to the chatbot pretty easily. So this is a query preprocessor. And if you want to learn more about this, it's documented on our documentation website.
Okay.
So we're going to make the step back prompting preprocessor and pass to it a LangChain LLM. I created a helper function here. LangChain. Here we go. And we're going to pass in our model and API key. We're using GPT-4 Turbo here as well for anyone curious. So this is our code. This issue actually popped up this morning. It's a silly little TypeScript thing where it wants us to have some hidden methods here that we don't have, but it certainly doesn't matter for our use case. So we are going to TS ignore that. Okay. Probably not best practice in your production application, but will serve us fine for this demo. So now we have this preprocessor in place, and we can try this query sequence again. What can I make with bologna, hot sauce, and relish? Let's find out.
So theoretically, it shouldn't give too different a response.
No. There we go. And if we look at the logs, we should actually be able to see the preprocessed content.
Oh, very cool.
So successfully preprocessed user query, original query. What can I make with bologna, hot sauce, relish? What recipes can be made using bologna, hot sauce, and relish? Question mark. So we get a little more semantic meaning there.
Yeah. So you're actually pre-processing. You're changing you're normalizing the question from the user.
Yeah.
Yeah.
Just mapping it into a better search query.
Okay. Okay. There's our recipe.
Oh, serve with potato chips. Good idea.
Yeah.
And what did we want to add?
Oh, let's add pickles.
Do you want to add anything else?
Let's see. What else we got in the fridge? Cheese.
Cheese. So let's see what we get for the preprocessor. So we get the user message, original query, preprocessed. What are some recipes that include bologna, hot sauce, relish, pickles, and cheese? So there you go. It has it all. And cheese and anchovy sandwich. Well, I don't know if we got the bologna in there, but yeah, this is the example for why you want to rigorously test and red team and then evaluate any generative AI application.
What are some interesting responses that you've seen? I mean, have you seen any bizarre hallucinations
for this or for other chatbots?
Well, I guess for any of your work with AI.
Yeah, I mean, certainly seen hallucinations, and it should be disclaimed, this framework will not solve hallucinations as a problem for you. Hallucinations are a problem of the generative AI age, at least as it exists right now. Sometimes for MongoDB stuff, it will make up methods. We've tried very hard to mitigate that with relative success. System prompting can help a lot to make it be like, sorry, I don't know. Because like these LLMs, they're like trained to try to be super helpful.
And they never tell you they don't know.
Yeah, you need to tell it to tell you it doesn't know. And even then, it will only do that sometimes.
Yeah.
Well, that's something that I suspect will get significantly better in the next year or two, because it's such a universal issue of this technology.
Yeah. It's one of the key ways search engines and AI differ, right? Search engine will tell you there's nothing found, but AI is going to always try and give you something.
Yeah. Yeah. It lacks that precision. And also in the chatbot framework, it's worth noting that if there is like truly no search results, then it will just say, sorry, I don't know how to help you. And that can help as well defend against these hallucinations. So if we were to ask about something like totally left field, like how do I aggregate data with MongoDB, I assume it will say, sorry, I don't know.
Ooh, let's find out. Ah, okay. Huh. PyMongo. It knows. Even though it's a Gilded Age cookbook, it knows.
Because Chat GPT knows. I'm not sure what content it would have found that could possibly match this, but that would certainly be something to optimize on when you are building and red teaming the chatbot.
Yeah.
For reference, this demo was made in a few hours. You should not put something into production on your website that you make in a few hours.
No, definitely want to test and red team for sure.
Yeah, I think that's extra important with this AI stuff.
Yep. So I'm interested in finding out how you continue to refine so that you can get into production. And you mentioned a component that intrigued me, the evaluation framework.
So this is fresh off the presses, was published to NPM last week. And more documentation will be coming soon on it, probably, if not this week, the next. But it lets you run a series of tests that assess the output of the chatbot on predefined cases. So you can have a configuration file that has like a set of questions on it and expectations of the output, and then assess whether or not the actual output meets that expectation. And we're actually doing that with an LLM in this test, but the framework is extensible, so you can add your own evaluations to include as well. Like we have one coming soon for evaluating not just does the answer meet the expectation, but if it's hallucinating when it's creating that, or is it grounding it in the retrieved documents?
Yeah.
Stuff like that. It's very, very helpful to assess as you are iterating on your chatbot.
Awesome. John is asking for a docs link, please. I'm wondering if Luce can grab that. All right.
And one last note to touch on is if you want to add this chatbot to your website, it's incredibly easy. Just a few React components, which you can find here.
Okay.
And that's all it takes. And then you can have it on your website, talking to your server and serving answers about the food of the Gilded Age or whatever else you want to ingest and discuss.
Okay. Super interesting stuff. What's next? Anything else you want to show?
So that concludes my demo. I have
Mhm.
some links as well that, if they're not already in the chat, people can check out.
Okay.
The repo, the docs, we tried to be pretty thorough in our docs, but we always can be more thorough. So if you have any questions or anything else, submit a GitHub issue, please, and we'll be on top of that.
All right.
Oh,
So,
and then if you want to try out the cookbook chat yourself, we have it live, deployed to the internet, and I will put
that's
that
the link
in the
I
chat.
created earlier. Yeah. GitHub.io.
So I'm going to put in the private chat, and then
Yep.
Mike or somebody else, could you add it to the public one?
Oh, very cool. Yeah. So this one, I'm going to ask Luce to put that in, but I'll create a banner. So this is I'll call it production, but I'll just say live version of the Gilded Age chat. Gilded Age Cookbook Chatbot.
The Gilded Age Gourmet.
Gilded Age Gourmet. There you go.
Yeah, we can thank Chat GPT for that name.
Yeah, fantastic. Okay, so thank you for that demo and for really diving deeply into that. I know we covered a lot, and if you're trying to follow along, it's probably going to be difficult at this speed. But like we said, it's all available on GitHub, so you can check that out. There's also a link below to the blog article that talks in depth about the MongoDB Docs chatbot. I want to ask you a little bit about like what's next in the roadmap for the Docs chatbot.
Yeah, so we have a few things coming up. So one, for the MongoDB Docs chatbot, we will be working on persisting conversations across pages. So the conversation can follow you around as you work through the docs, because right now it's just new page, new conversation. Additionally, we will be adding to the framework a few more evaluations, which will allow us to experiment some more with various different prompting techniques and using different models and quantitatively assessing the impact of those changes. It's like right now we know that GPT-4, for example, works better than GPT 3.5. And I mean, you can just tell that from look and feel, but it would be great to be able to have some numbers associated with that. And maybe then we could try out some other models like Mistral or Google Gemini and see how those affect the chatbot performance, also taking into account things like price and performance, and really optimize the chatbot for our users while also not fully breaking the budget.
Yeah. Yeah, that's always a challenge, right? You never know how much it's going to cost until you know how popular the project is going to be. Was that a shock for you when we went into production with the chatbot?
Cost wasn't too bad, and still isn't too bad with GPT 3.5, which we're using in production. And
why not 4?
So two reasons. One, price. It could get pretty expensive pretty quickly if you're using GPT-4. And two, there's some resource limitations if you're using GPT-4 through Azure, whereby like just the amount of usage that you can have isn't that high because there's only like so many NVIDIA GPUs in the world, and a very small sliver of that are publicly accessible to any one account.
Yeah. Huh. Awesome. Well, this has been a great discussion, coming up on 50 minutes. Anything else you want to share with the audience before we begin to wrap up?
I would just say that if you have any questions about the chatbot, feel free to find me on the internet. I'm around. Ben Perlmutter on LinkedIn. Happy to chat there. And also feel free to put a GitHub issue up. We look at all of them and we try to respond and maybe even implement whatever it is. We'd love to hear from our users.
Fantastic. Well, make sure you check out the GitHub repository. Check out the links below for a blog article talking in depth about the chatbot framework. Ben, thanks so much for joining us today. I appreciate it.
All right. Thank you, Mike.
Have a great day.
Bye.